Thank you.
Take it away.
Thanks for the introduction. Are there any other Australians here? So, thought so. Yeah, so my name is Kevin. I'm a front-end developer at Kucharczyk. And it's really lovely to be here because, as you may have noticed, I don't always get a chance to come here. It's just very far away. So it's really fun to be able to attend and speak, especially. And seeing, I think I recognize a couple of you from previous conferences. It's just lovely vibe. So hey, nice to meet you. Today I'm here to talk about a new feature that's probably maybe coming to Ember called Context, and how it can help you build better components, but also what to watch out for when you're using it, and maybe tell you not to use it in certain situations. So let's dive in. Earlier this year, about 3 months ago, I was in New York at EmberConf giving a very similar talk to this one. I was introducing the concept of context to the Ember community. And if you haven't watched it, it is available on YouTube under this QR code. And I realized this looks exactly like a Chris Manson slide from earlier today. I swear I prepared this one before I saw his talk. So you can see the talk there, but it's not mandatory to watch it. This talk today is a little bit different. But I'll still introduce all the concepts, I hope. But I do recommend it. It takes a different angle on the context concept. So today I will be talking about context from a different perspective. I'll add a little bit more nuance than I did in New York, and we'll explore the situations when you shouldn't use context. In New York, I was very much about, hey, let's use context, it's great. Today I'm taking a little bit of a step back and be like, hey, let's take it slow and figure out which use cases actually make sense. So for some of you who don't know what context is, here's a quick introduction to the concept. The apps we build are all made up of components. It's all HTML. The relationships that they have between each other, they form this sort of tree structure. You have parent components, child components, and all of these nodes here in this graph are components which render other components. Each of these renders its own sub-tree of components. And when we render these components that are nested with one, we pass various arguments into them, like state or configuration options, callbacks, all sorts of things. And you may sometimes need a certain argument at a deep level. And in order to make that happen, you have to pass it through all these layers, through all the components. And sometimes some of these components, they don't need a certain argument, so all that they're doing is passing it further. And this concept is called prop drilling. And context is a way to avoid that problem. Instead of passing through this argument through each layer, a component that needs that data can refer directly to what we call the provider. It just references that provider and asks it for the data without having to pass arguments through multiple layers. In Ember terms, this is something like a service where we inject the service into our components, except context is not global like services are. Context is more tied to a particular component subtree, and it doesn't live globally outside of that. And context is fairly well established in other frameworks like React, Vue, Svelte. They're very well known under these names. You can look up the docs if you'd like. And at Ember, it's not quite available yet. There's an RFC here, which you can again look up with a QR code. That seems to be a theme today, QR codes. You can comment on this RFC, and I would like to invite you to do so. This is something that we're doing together as a community. The RFC is currently in the exploring stage, I believe. There is some support from the Ember core team. So chances are this will make it to Ember, but I need your help to help me explore the use cases and what the shape of the feature should be. But you don't have to wait for the RFC to land, because there is an add-on available now that allows you to use it today. It's got a very long name. It's called Ember Provide Consume Context, and that's because Ember Context was already taken, so I had to choose this. And in this add-on, there are two ways to use context. One of them, which you can see here, is through decorators, which are quite similar to how we use services in Ember. A component can act as a provider by attaching the provide decorator to a getter, which could reference the component's arguments or tracked state. Or we could attach it to a static property. It doesn't have to be reactive at all if you don't want it to be. And you also have to give the context a name, which is then used on the right side here to retrieve the value that you're providing. And to retrieve it, you use the consume decorator. And then whenever the provided value changes, if it's reactive, your component would also re-render just as if it was a service or an argument. There is also two components that you can use instead. There's context provider and context consumer, and they work the same way as the decorators. You give them a name, you give it a value, and then you can use this name to retrieve the value of the context in context consumer. In context consumer, the value is yielded through Ember's special yield keyword, which is quite unique to our framework, and it lends itself quite well to this sort of use case. So you can use this in Ember and Ember's template-only components when you don't have a class to attach the decorator in. So now we know what context is, and now how we can use it. So we'll look at some examples. There will be some code. But I'd also like to take this opportunity to tell you, like, this is not a tutorial to tell you what to do and not to do. I'm here to promote the idea of context and to get your input so that we can all together make this happen and make this into a good feature that makes sense for all of us. I built the Ember Provide Consume Context add-on because I wanted to use context in our app, but there's so many more use cases than just this one app. So I'm here to promote the idea and get your feedback. But now let's dive into the examples. So the reason why I built this library is because I was building a new design system and component library for our app. And I found that its context is really useful in this sort of situation where you have these configurable and composable flexible components, because it allows you to compose them freely without having to worry about internal implementation details. So here, as an example, I have a radio group component and radio components inside it. Radios, as you know, they always come in groups. You can't have a single radio. It wouldn't really make sense. And they're all connected together through a name attribute, usually. For us, we built the radio group component to keep track of the state for the whole group and then provide it to the individual components so that they can make use of those values and attach certain callbacks without the developer having to worry about all those internal details. You can see here, this is actual code, this works. But internally, these radios, they would still know what the current selected value is or whether they should or should not be disabled. And to clarify that a little bit, we'll look at the actual implementation of these components. It's a very simplified one. Here we have the radio group component, which is used to wrap the individual radios. And it provides a context, which we named radio group context, makes sense. And this one shares a couple of things with the whole group. It has the currently selected value, which comes from the arguments, change handler, whether it's disabled, and it also provides the name. If we don't provide a name, one can be generated automatically, like unique to this group, so that as a developer, if I don't care about what this group's name is, I just don't pass it in, and I can trust the component to do it automatically for me, so I don't have to worry about certain internal stuff happening in there. Then it renders some sort of label, yields, so that we can insert the individual radios. And not pictured here would be additional attributes, like ARIA attributes, because we could also generate stuff like IDs that we could then apply on the label and the radio inputs to tie them together accessibility-wise, so that as a developer, I don't need to do that manually, and I can trust my component to be accessible automatically, magically, straight off the bat. We'll have a look at the individual radio, which you probably saw coming. This one consumes the radio context, or radio group context, rather. It compares its own value to the one coming from the radio group to see whether it should be in the checked state. And we didn't have to give it that current value. It can read that from context. So I, as a developer, I write less code. It also uses the context change handler to notify the whole group when it's been clicked and when the selected value has changed. And it also uses the context disabled state. This way, all radio inputs that are nested within this provider automatically become disabled when necessary, and I don't need to repeat this disabled attribute on all individual radios. So as a developer, I can focus on building the features that sell, the features that make money, as Preston said. And I don't have to worry about the internal details of all these components. I can just move on and build stuff. So this is one of the examples where context works well, and this is reusable components, like composable, configurable, component library type components. And here's another example of that, a tabs navigation sort of component where when you click the tab, it should change the content to the appropriate one. We have split this up into a couple of components. You can see here there's the top-level tabs, which provides the context and manages the state. We have the tab list, which renders the buttons, and we have the tab content for each of the respective buttons to match with. So we'll look at the implementations again. This one is the top-level tabs, and much like the radio group, it provides a context with the current values, handlers, and so on. But unlike the radio group, we've made this one manage the whole state internally. It doesn't accept an argument for the currently selected tab. We could, of course, but what we wanted to highlight here is that a provider component can act as a higher order state container sort of component where it manages state, it initializes state, and then gives certain abstractions to you, but it itself doesn't do much else. It doesn't render anything into the template. It only yields, which means that it doesn't contribute to the HTML tree. It doesn't contribute to the CSS cascade, so you can style your components freely, and you can compose the internals however you want. And we have the tab list, which doesn't do much. It doesn't handle any internal state itself, so we made it into a template-only component. But in order to consume the context, we can use the context consumer component still. We have access to the context with the yielded value, and we render a styled div to wrap the tabs. We iterate through the tabs to render a tab item, which are the buttons at the top that you saw or still see. And we won't be looking at tab item because that would be essentially identical to the radio from before, where it renders a styled button. It would read the current value to see if it's checked. It would attach change handlers or click handlers in this situation, and maybe become disabled if necessary. And finally, we have the tab content, which all it does is conditionally render the content of the tab it's attached to. So what it does, it checks whether the content or whether the tab it relates to is currently active, and if it is, render the content. So this way, as a developer, I don't have to worry about writing the conditional code within my components. I don't need to worry about repeating the piece of code that says if current tab is equal value, blah, blah. This is all handled internally within tab content. And if it's not active, it just won't render the content. It also generates an ARIA attribute, which, like I said before, can make our life easier by automatically making our code accessible so that I, again, can focus on writing code that makes money. But it's also accessible because we want everyone to be able to use our apps equally. So this just takes a little bit less work for the developer to make things happen, I would say, correctly. So we'll add to our summary here. We have more use cases for when context really shines. In both the radio and tabs examples, we want state to be injectable in like a service-like fashion, but it's not entirely global. So we've restricted it to a group of components or a subtree of components. We can also see how context can aid composition by allowing us to access state no matter how deep we are in a tree. And we can then add extra styles or move components around. And we always know that the context will be accessible where it's needed. And here's another example that's really fun, which is automatically implementing heading components. And I think I saw this one on Discord. I'm not sure where the person is that had posted this, but this is great because when we use H1 to H6 tags in HTML, it's very important for nested section to increment to the next level of the heading to remain semantically correct. But sometimes when we write code, it's not immediately obvious what level we're at. When we're writing our code, our component, we write it in isolation. But when it's rendered on the page, we just don't know how many components are above it. So we can write a provider that reads the current provider level if there is one above it, and then increment it so that all further children will have the next level. It then provides that context, and inside it we can render headings, which simply read the context and then render the appropriate heading tag. We then put these together, and we can see that the levels or the headings, they get their correct levels automatically, even though we didn't specify that at all on the left side. This is the real output of the code that I wrote. But in real life app, you probably add a bit more nesting. Like you'd have the heading provider maybe render section tags or diffs if you'd like. It just didn't quite fit on this slide. But you get the idea. You, as a developer, you use the heading component wherever you need a heading, and you move the responsibility of figuring out what heading level to use to the context provider. So this is another point in our summary where we want to make state available no matter how deep we are, and we also don't want to worry about how deep we are. We just want this stuff to happen magically, which context does really well. So you might be thinking that, well, okay, if context is so great, why are we still using arguments and services? Let's just drop all that. I don't need to pass arguments to my components. I'll just make everything a context provider. But it's not meant to be this way. We're not meant to replace context or arguments with context. Context is just another feature that's available to us in addition to the other state sharing patterns that exist in Ember. It's just another tool. So overusing it can lead to some problems, like the spooky action at a distance issue that Preston mentioned in the previous talk. In 1947, actually, Albert Einstein wrote a letter to Max Born, another physicist, where he expressed concern about quantum mechanics. He wasn't quite sure if he believed it was real. He criticized it by saying this weird spooky action at a distance happening, referring to phenomena like quantum entanglement, which allows particles to instantaneously communicate some sort of state, even then there's no interaction happening between them. And it's a great way to describe what's happening in context or in effects, I suppose, where sometimes you don't know where your data is coming from. If you're working on a component that consumes a context, you can look up the provider's code, and you can read what sort of state it provides. But in the actual app, once everything renders, it's not quite clear where the data is actually coming from. In order to debug the situation, you would need to go through each level and read what sort of data it might provide. So debugging is really hard. So we need to remember to use other state sharing patterns when they might be more appropriate than context. And the ones we'll look at today are services, of course, contextual components, which is unfortunate naming for today, and regular prop drilling or arguments. So services are well known. I think all Ember developers use services in all their apps. I don't think there's an app that doesn't use a service. And these are great for when your state is truly global. A good indicator for deciding whether context or services should be used is whether there is a chance if your state will need to be overridden for a particular component subtree or changed at some point. And if you decide that your state is truly global, you might want to stick with services because they were built for this purpose. They are supposed to be global state containers. So we'll add this to our list and move on. There's contextual components, which is not context components like I described a couple of slides before. This is what we name this pattern in Ember where we use the yield keyword with the component helper to make a component available to the caller that's already got some arguments pre-filled. We say we curry that component, and then the caller can use that as if it was any other component with skipping some of the arguments. So here we've rewritten the radio group from before to be a contextual component, and it looks basically the same, but one benefit we might get here is type hints, for example. With glint, we can see what values a component yields. So when we're writing the code within the radio group, we can see that it gives us a radio component to use, which is not something you can do with context. You have to read your component library's documentation to know that there is a radio input component for you to use. So if there is a direct parent-child relationship between components, and there's only one level of nesting between them, it might be better to stick with this. It gives you a lot of benefits, and it makes the code a little bit more readable in those situations. If there are more layers between the parent and the child, you might need to take the child and pass it through arguments to your deeper components if you still want to use them, at which point it's worth considering context. So we'll add shallow nesting, what I just described, to this summary. But we can also use the contextual components pattern for restricting composition. Sometimes we would maybe want certain components to be arranged in a very specific way, or we don't want developers to be able to use child components outside of their parent. So making those child components only available through the yielding pattern can help us make that happen. We have like very strong opinions about how to use a component. This is the way to do it. Another great indicator for when to use or not to use context is whether your component handles business logic. And I think this is probably one of the biggest discerning factors. We saw earlier that context works great for reusable components, composable sort of component library ones. And one of the reasons for that was because we don't usually care about the specific implementation details within those library components. But when working with components that include application logic, it is often better to handle their arguments a bit more explicitly so that developers know what actually happens when they read the template code. Not using arguments would probably obfuscate some of the code, and it might make it harder to debug it. So we've chosen to repeat arguments, good old-fashioned prop drilling in the child components to make it clear what's happening from an app's perspective, from a business logic perspective. This way, so when we read the code, we can just skim it and sort of see how a component is configured. It also, this pattern might make it easier to modify code as your app grows or requirements change. Because when a component uses context, it's actually more difficult to do refactors. Using context implicitly couples the consumer components to their providers, which makes it harder to change the code. And depending on the complexity of your business logic component, you might end up with dozens of arguments to make a certain thing happen. So this can be addressed if we wrap up certain functionality into one little state container, you could call it. And change sets is an add-on that could describe the situation well, where we wrap a class or object into a container that also contains things like validation or dirty tracking. And then instead of all these arguments, we pass in that one, here it's called view model, this sort of container, which is then easier to pass through all the layers. It's still prop drilling, but we've reduced 20 arguments into one, which is easier to maintain in your code because you don't have massive templates that just repeat arguments over and over. And this view model here could also just be an embed model where you also add a couple of extra methods or properties for handling that business logic within your form. So we're adding another factor to consider, whether or not to use context, which would be business logic, which is what you're building this app for. So often when I'm building our components in our app, I never reach for context first. I only add context to application components when I notice that it would actually improve things and make things more readable. So context should probably be the last thing to consider in app code. But you can, of course, combine the patterns as well. You don't have to choose either or. You can use context and yielded components or services at the same time. At Custom.io, we have a set of filter editor components all throughout the app, which allow our users to build these filters or conditions. And you can use these filters for many different things, depending on where you are in the app. You can use it to search for people based on a certain attribute, or you can decide whether or not to send a message based on these filters. And they're all based on the same sort of subset of components. All the same child components are repeated in the condition editor. It lives everywhere in the app. But depending on placement, we might want the child component to render a little bit differently, in a different layout or in a different order. And to a certain extent, that might be possible with CSS only. We could use media queries or container-sized queries to arrange them differently, but we wanted to specifically tell these components to render a different way. But this is a classic example of prop drilling, where we have a couple of arguments that control this layout, and we had to pass it through all these layers, through all the components, to make sure that it reaches the component that actually cares about it, like the cancel button. where a lot of components along the way just really don't care about all of these arguments that we're passing through. So we use context at the top level to provide the configuration values, which then the child components can read. And then we don't need to repeat all these arguments through all the child components. But we still keep the business logic or the configuration arguments at the very top level. So the top level component takes those arguments, but then it itself acts as the provider to all the child components. So you can still configure the top level component with your business logic, and internally it does all this magic that you don't necessarily care about when building out your feature. You just want to build a filter, but you don't need to worry about what the individual components within your filter are doing. Another style thing that these components could benefit from when it comes to context is changing styles depending on level of nesting. In our app, you can sometimes build nested conditions. And to make it easier for users to understand what is going on with your filters and to make it easier to read your condition, we flipped the styles between the different nesting levels. And I don't think you can see that. It's the same problem from before with the workflow builder talk. The top background is like a light gray. Then we flip to white. Then we flip it again. You have a gray. I'll share the slide so you can see it better. But this is essentially what you saw with the heading provider, where at each level we increment the current nesting level in a provider so that all the components nested within can render accordingly without us having to repeat the level through each component, even though most of them would not care. And finally, it's not all just styling that changes when we use context in our filter editors, because sometimes we might actually want to change what options are available for building the filter. On the left, we have a filter that compares the value to a regular string or to another attribute on that customer. Or if we're in the context of an action that can be triggered by certain things, we might want to give the user more options to build that filter, but only if it's actually supported within that action. And again, in order to make that happen, we would have to pass arguments through all the levels, only for it to reach this one select component where all the other components don't actually care about whether I am in a event attribute action or not. Additionally, you might want to show additional contextual information to your user to help them make better decisions on what filters to build. Like here we show the event name so that they know what these values actually refer to. So again, we've mixed the context pattern with arguments to build components that a developer can use to be productive, but that don't stop us from building these interfaces or changing things in the future. So at the top level, we pass in all the business logic and all the arguments, but internally, we provide those arguments as a context so that all the child components can read it. So I, as a developer, I just invoke the condition filter and tell it to, yes, include trigger event attributes. And that configuration option will reach the child components that care without repeating the argument through each level. And we also use the state container pattern from before here, where the condition or the filter setup is actually a class itself. So we pass in one argument for the class and the business logic, and all the other arguments are sort of the contextual configuration about where this condition filter lives in the app. So to summarize, context is a really cool tool for sharing state with various child components. But just like any other design pattern, we really have to carefully examine whether this is the right pattern to use for a certain use case. I would like you to take away from this that we should not be using context everywhere. There are other patterns that are often more appropriate. But I would also like to encourage you to start trying context in your app and then hopefully tell me how that went. We are building this feature together. I would like to have this RFC merged and ship into Ember one day. But like I said before, we are only one app, and we have a certain number of use cases for context. And I would love to hear from you about your use cases and how you're planning to use it, how context solves your problems, or maybe how context made your app more difficult to maintain. So please comment on the RFC, start using the add-on, and you can reach me in the Ember Discord on the this handle, which is unpronounceable. So thanks for listening. I am here, of course, today and tomorrow to dive into this more if you want to chat. And please enjoy the rest of the conference.